Very excited to have her back. Krishna Sankar is a doctoral fellow at the University of Toronto in the Faculty of Medicine. She is currently completing her PhD research where she combines biology and engineering to improve islet transportation for diabetes treatment. And I'm sure she'll tell us what that means if you don't already know, because I don't. I'm a physics person, so I'm looking forward to that. She's a co-founder of the University of Toronto Diabetes Canada chapter, and she educates the public on diabetes research. So that's why she's here tonight, spreads diabetes awareness, and advocates on behalf of people with the disease. And additionally, she co-founded the Women of Color in STEAM Canada, that's at WOCSCAN, a not-for-profit organization advocating for minorities in science, technology, engineering, arts, mathematics, and medicine across Canada. You can follow her on Instagram at Beyond the Ivory Tower and at Twitter at Krishna Sankar. And I also just want to mention one particular initiative that she's involved in that I think is great. There's a book called Inferior, which is all about how science has done interesting research about women. It hasn't always necessarily been particularly good science. And so it's colored people's perceptions of women. And this book, Krishna and some of her colleagues are attempting to get into all high schools in Ontario, Canada, three boards? Three provinces in Canada, so that people can hear about this. And if you're a long-term attendee of these talks, we actually had a speaker on this very topic, and I can't remember her name, but I'm going to look it up, about 3 years ago, and it was fascinating. So we're looking forward to supporting you in that effort. So please join me in welcoming Krishna Sankar.
My name is Krishna Sankar, and I am a diabetes researcher at the University of Toronto. So my topic tonight is no sugarcoating, and yes, that's a play on words, just because, as was mentioned, yesterday was Halloween. And I wonder how many people in here indulged in Halloween candy last night? Yes, that's right. Got your fill of sugar. And also, I'd like to know if there are any people in here with diabetes. If you're comfortable raising your hand, please do. Great, thank you. So here are our diabetes heroes in the audience. Thank you for coming tonight. So I'm just going to give you a lay of the Candyland as per se. So this is my agenda for tonight. I'll be giving you guys some facts and figures, so some hard numbers as to what, as to what we're dealing with when it comes to diabetes, a brief history of diabetes in Canada, look at diabetes and sugar in our bodies, and me fighting diabetes at the bench. Actually, can I take this off? Yeah, I think this will be better. So me fighting diabetes at the bench, and then other ways in which I fight diabetes, and other ways that you all can help in fighting diabetes, because it's a disease that not only affects those who has diabetes, but also all of us. So I'm starting with something a little bit funny here. Hope no one takes offense, because it's one of these where you find what society thinks you do as a student or someone in a profession. So as a person with diabetes, this is what society probably thinks you do, right? They probably think you pick out and eat a lot of fast food, what media thinks you do. So we've got a little picture there of Paula. What your parents probably think you do is just eat a lot of candy. What your doctor thinks you do, so you have a lot of medication. What you think you do, so the superheroes in here that raise their hands. And what you really do. So what you really do is you just live your life. You just go about living your life. You may or may not be afflicted with this disease, or you may or may not have a direct family member who has this disease. So I'm just going to play a little game with you guys tonight. Please feel free to just scream the answers out, shout them out, or raise your hands. I call it trick or true, and this is just a little ode to Halloween. Okay, so first question or first statement for you. Eating too much sugar causes diabetes. Who thinks this is a trick, or who thinks this is true? True. How many trues? Well, I had a bunch of trues over here. Trues. And how many tricks? Okay, so I think some trues changed to some tricks. Okay, no problem. So this is a trick. So it's a very big misconception publicly and globally that eating too much sugar causes diabetes. That is not the cause of diabetes. Diabetes is caused by several different things, including genetics, as well as your environment. And guess what? It's not really just sugar. It's actually eating fatty foods, particularly in type 2 diabetes, and having a sedentary lifestyle. That is part of the cause for diabetes. Second one, insulin is a cure for diabetes. True or trick? Oh wow, okay, everyone's on board here. Yes, that is a trick. So insulin helps people to live a longer life with diabetes. However, once you have it, unfortunately, it's an incurable disease right now. Hopefully it will be curable within our lifetime, but it is not a cure for diabetes. Thirdly, diabetes is a serious disease like cancer or heart disease. True or trick? True. All right, true. Good job, guys. So yes, this is true. Diabetes is indeed very serious. It's extremely complicated. A lot of people tend not to take it as seriously just because we hear a lot of media attention for diseases like cancer or in the past HIV. But diabetes is extremely complicated and actually leads to complications if you're not properly managing it, and can eventually lead to heart diseases, strokes, blindness, as well as limb amputation. So treating this disease is extremely important. And last one, diabetes is a disease of the pancreas. True or trick? True. It is true, but there is a trick to this. So, like I just mentioned, diabetes is actually a disease of the entire body. It's not just of the pancreas. So it affects your heart, it affects your brain, it affects your liver, it affects pretty much every organ in your body. So it is not just a disease of the pancreas, although that is part of it. So let's just go through quickly some facts and figures. So here are just some facts and figures about diabetes that I think are very important for everyone to know before we get to the more exciting stuff. So currently in Canada, we have over 3 million people with diabetes, and over 6 million people are living with pre-diabetes. Now, pre-diabetes means you're on the borderline to getting diabetes and you're not quite there. You can probably pull yourself back, and that's for people who will eventually or may eventually develop type 2 diabetes. This, of course, is not for people with type 1 diabetes, because that type of diabetes is an autoimmune disease. 1 in 3 people with diabetes, they don't know it yet. So this is where testing and seeing your healthcare provider or professional is very important as frequently as you can. I would urge everyone to get tested for diabetes. Type 2 diabetes may be prevented or delayed. So this one is very important. So currently there's a huge economic burden on our country because of healthcare, and one of the leading causes of healthcare issues is diabetes. As I just mentioned, so the cost of diabetes in Canada is currently about $12.2 billion, and so this is taking into account taxpayer dollars, but even more importantly, those of you who have diabetes, you know how expensive it is to manage it. So first of all, you have your insulin injections if you're taking insulin, you have the cost of the other medications on top of that. If you're using a patch, you have the cost of the patch, you have costs of monitoring devices. There are a lot of costs involved. So this is a disease that is not financially friendly. So let's look at a brief history of diabetes in Canada. So as was mentioned, November is Diabetes Awareness Month, and I will tell you why it's Diabetes Awareness Month, and it's not a coincidence per se that it happens right after October 31st. So World Diabetes Day is November 14th, and that's because of the birthday of Dr. Frederick Banting. So he was one of the co-discoverers of insulin. Now every year the IDF, or the International Diabetes Federation, has a theme for diabetes, and this year it's family and diabetes. And so that's because they're looking at the effects that diabetes can have on families, and vice versa, the effects the person themselves feel having diabetes has on their family. So looking at the mental health aspect of diabetes as well as the physical aspect of diabetes. So diabetes within Canada, Toronto, Ontario specifically, so Banting and Best, so this was already mentioned, but I'm going over it anyway. So they discovered insulin. The discovery started in 1921, experiments being finished in 1922, and it was all done at the University of Toronto. So here I have a picture. This is Banting, and this is Best. So Dr. Banting was the supervisor. Best was his medical student, and this dog here, her name is Majorie. And she's actually the dog that they did the experiments on, where they were able to find, once removing the pancreas, they saw that there were symptoms similar to people who had diabetes. And on putting the pancreas back in, they noticed that the dog was better. So they received a Nobel Prize for this in 1923. It was actually Banting who received it and shared it with Best. It was also, the Nobel Prize was also awarded to McLeod, so he was in charge at the time when Banting and Best were doing their experiments. So before its discovery, absolutely no one survived who had diabetes, and that's because it's a disease without, if you have no insulin, you cannot live. And so obviously the moment insulin was discovered, it was actually sold for $1, a $1 patent, and that was so that everyone could have access to insulin, but that was, of course, back in the day. Now insulin is very expensive. And so there's currently treatments, but no cures for diabetes. So we're just going to look at over a basic overview here of how sugar would work in your body. So I've got a little outline of me. This is my pancreas, and this is some Lindt chocolate. Okay, yeah, that's because I like Lindt. So this is me eating the Lindt. Oh, and then as we eat, our body starts to break down whatever we eat into its components. So it starts to digest into sugars and other components, and of course it's Lindt, so there's a whole lot of sugar in there. So what happens is that when we eat something and it breaks down, it goes into our bloodstream, and our blood, of course, runs throughout our body, including the pancreas. And when it gets to the pancreas can sense what's going on in our bodies. When there's a certain level of sugar in our pancreas, it actually causes a release of insulin. So my insulin here is indicated by keys, and that's because insulin is actually the key. Once it's released, it goes and visits different organs within your body so that they open up and remove that sugar from your blood so it can be stored for use later on. So here again, we have the pancreas, which releases insulin. And then I'll show you a bunch of other organs that are involved in sensing insulin or in diabetes. So the gut in particular is actually something new. So there's more new research happening within the gut to show that there's certain hormones that are involved in diabetes in the gut. The muscle, the liver, and the fat. So these three organs here are very important when it comes to absorbing and storing sugar. So I'll give you an example. You're coming here today in the traffic. Can you imagine just coming in and being stopped at a bottleneck and not being able to go anywhere else, right? Everyone would just be all packed like sardines. We'd start to be all inhaling all the fumes. It just won't be good for us. So if your sugar gets into your body and it's just all packed in your blood, it starts to do very, very bad things. So the insulin, what it does is it goes to these different organs in our body, opens it up, and actually allows a pathway for the sugar to move out of your blood and to then get stored within different organs in your body so you can use it later on for energy. So the liver also produces glucose, but that's just when you need it. The brain, of course, is involved in everything. And altogether, this again, I just want to reiterate, remember that diabetes is not just a disease of the pancreas, but a disease of the entire body. And hyperglycemia, so that's just a term meaning high blood glucose. And that's what happens when you have too much sugar in your blood. So now I'm going to talk about a little bit about my research that I do at the bench. So currently, diabetes research is happening from very many different angles, in different areas, and we're all trying to target diabetes from a different lens. Currently, there's research going on in genes and regulation of genes. There's also cells and protein signaling. There's nutrition and diet, which of course is self-explanatory. Drug mechanisms, so people are looking into different drugs and trying to figure out, are they working? How are they working? How well are they working? What the side effects are? Diabetes complications. So once again, the complications like I was mentioning, heart disease, stroke, amputations, and blindness. And then epidemiology. So earlier when I was able to give you those numbers of, over 3 million people suffer with diabetes, over 6 million people have prediabetes, that's the work of the epidemiologist. So me in particular, my work is very different. It's not clinical. I'm one of those people who do work at the bench. And so my research is more at the cellular level. It's cell-based, and I'll be getting into that. So, islet transplantation. I think this was mentioned in my intro. So islet transplantation, it sounds very complex, but it actually isn't. It's a transplantation of an islet, and I'll tell you later what an islet is. But right now, it's a treatment. It's a type of treatment for type 1 diabetes. And it started in the 1970s, but unfortunately, there hasn't been a lot of success until the 2000s, and that's with Dr. Shapiro, who's a Canadian up in Alberta. Typically, this procedure requires at least 10,000 islets. Now, when I say 10,000 islets, it sounds like a lot, but we typically have a lot more of those islets. The reason this is an issue is because usually we have to take this from someone who's just very recently deceased and be able to get it out of their pancreas and then transplant it into someone who has type 1 diabetes. So I'll briefly go through this process here with you. So this is the pancreas here of a donor. So this is someone who has just very recently passed away. We remove the pancreas. We do a procedure where we isolate the islets. So the islets are little balls of cells that you find within your pancreas. After that, we are then able to inject it into the hepatic portal vein. So this is a vein of the liver. And that's usually where it's done. And then the recipient is left with this injection of islets in their portal vein and then monitored. This is usually a very quick procedure. It's not very intensive. However, there are several issues, of course, that are currently still aligned with this procedure, but one of the biggest issues, and the one that I'm currently working on, is the fact that if you think about it, if you cut something, so for example, imagine you cut your arm off. Yeah, who wants to do that? And then, or someone else needs an arm transplant. There have been lots of different types of transplants happening. It's very important that all the blood vessels from within that organ or that limb is able to now reconnect with a new arm in order for it to work. So the same thing goes for these islets, these tiny balls of cells. When they're cut, they actually are cut from a blood supply. And so when we put them back into someone, it's very necessary. They have to make reconnections into that new person. Otherwise, what's the sense? They won't work. And then once again, that person will have to go on insulin and rely on insulin. So like I mentioned, this is a treatment for type 1 diabetes, and that's because insulin is very necessary for people with type 1 diabetes because they cannot make any insulin on their own. So this is what an islet is. I have 3 different images here. This one here happens to be what you see if you just look through a microscope. Just looking through a regular light field microscope, this is what an islet looks like. It looks fine, it looks kind of boring, it's just like a round ball, okay. This is a cartoon picture of what an islet looks like. I kind of like it more. And that's because this sort of gives you an idea of what's going on in there. It's a ball of cells like I mentioned. And it actually is made up of 4 to 5 different types of cells, as well as these little strings here, which happen to be the blood vessels. They're blood vessels and nerves. The third picture here I'm extremely proud of, although it probably looks a little bit fuzzy, and that's because this is an islet that I just freshly took out from a mouse. I was able to fix it in time and then put some staining on it so that we actually can see here, these here are actually the blood vessels within the islet. It's pretty cool. So here, this is what an islet looks like, well, at least a mouse islet, freshly isolated from a mouse. And I'll show you a little video of what it looks like running through the islet. So remember, the islet is actually a sphere. It's not a flat ball of cells, it's a sphere of cells, it's a 3D model, or a 3D shape. So if you look at here, so this is actually what the islet looks like going from top to bottom through a very high-tech microscope. So what I was trying to do basically in my experiment is get So A here is a fresh islet that I just took from a mouse, and B is an islet that we had sitting inside of a dish, inside of a media, for about 24 hours. So why we do this experiment is because when we actually remove the islets from a person and try to then transport it to the next person, this has to be a very quick process. However, sometimes it's not. Sometimes they need to hold the islets back in order to remove certain things that might not mesh well with the next person. And so for that purpose, it might take them a bit longer than a few hours. But what you notice here is that all the staining here, actually there's far less here. So what does that mean? That actually means there are far less blood cells that are in these islets compared to these islets. And these islets here we call, are cultured in something we call a dish. So basically we house them pretty much in a petri dish. They're just sitting there in a dish. And this is what happens. So there are many processes that happen. Basically over the 24 hours, those cells start to die. And so my experiment, one of the aims of my experiments is to try to make sure and maintain that these islets, these blood vessels in these islets stay alive for a lot longer. To do that, I actually am combining biology and engineering. And so this is an image of the islets again. So this, of course, is not with such a huge zoom. This is a smaller zoom. These are the islets here all loaded up in something I call a microfluidic device. So basically, it's just a device that holds the islets. And this is what the device looks like from the outside. So this part here that you're seeing is actually this tiny, tiny part over there. So the size of one of these devices is about the width between my fingers, or the length between my fingers. And basically what happens is I put the islets into this little device here, and I simulate what they would normally find happening within the body. So remember when we take the islets out of the body and we transport them to get transplanted into someone else, they're no longer seeing this flow of blood through them. So in order to sort of assimilate this, we do this within this device. And so far, what we found is our results are that in comparison to A, we're currently seeing C, which at least is better than B. So this is one of the huge examples or results that we've gotten from our experiments so far. So like I'm saying here, C is better than B, but it's still nothing like A. And that is why research takes forever. It's one of the reasons because just getting to this point took a very, very long time. It required a lot of troubleshooting, a lot of hit and misses, a lot of errors in order to get to this point. But of course, we have to continue on, and then the next steps after that would be transplantation into mice with diabetes to see how they would actually react. So that was a little bit about what I do at the bench. Now, looking at diabetes beyond the bench. So this is a fun little thing I did last year, which I had lots of fun with and I'm proud of. It's called the 150 Minutes for Diabetes Awareness campaign. I ran it on social media. These are just some pictures of some of my social media, my fellow social media science family. And the reason for this is that 150 minutes of moderate to vigorous exercise has been recommended for people in general. So people generally with or without any type of disease. Usually it should be a mixture of aerobic and resistance exercises. So when I say resistance, I mean anything using a little bit of weights. Of course, I would suggest starting slowly. So start with something that you actually enjoy doing. So for myself, I enjoy dancing. I started with Zumba classes, and eventually you can move on to something else. And it's really important to have a support network. So I'm shouting out to my 3 Zumba buddies over there because they're my support network when it comes to exercising. It's always great to have people who are on board and helping you to live a better, healthy lifestyle. So I'm running this campaign again this year. And basically, if you have Instagram, what I ask you to do if you wanna get involved and contribute, all you have to do is take a picture of some time you've actually done some physical activity, hashtag 150 minutes for diabetes awareness, and then challenge your friends to get on board and do the same. It sounds difficult, but it's actually, if you divide it, in 3 days it's 50 minutes, in 5 days it's 30 minutes. It's not that bad, you can get it in. So another way that I fight diabetes is through advocacy. So this is me here with a couple of Diabetes Canada people and an MPP at Queen's Park. And so usually every November 14th on Diabetes Awareness Day, we head to Queen's Park and we talk to the MPPs about the different strategies that Diabetes Canada is putting forward in order to fight for people with diabetes. So currently Diabetes Canada has something called the Diabetes 360 strategy, and so those, I think the volunteers from Diabetes Canada can tell you more about it. And then for people who want more information about that, here's a number you can call, 1-800-BANTANG. You can also visit diabetes.ca. And Diabetes Canada has lots of ongoing events. So for example, they have lots of different types of presentations going on. They usually have booths or tables. And there's a lot of invaluable information you can get from either their website or talking to people from Diabetes Canada. So getting to the end here, a few things I want you guys to remember. Eating too much sugar does not cause diabetes. Diabetes is a complicated disease of the entire body. Insulin is not a cure. Well, you guys knew that one. And complications from diabetes can lead to these things. So heart diseases, strokes, blindness, and amputation. Things that you do not want happening to you. And with that, I'd like to close by saying you can find me here on social media, and these are just a couple of pictures. So this is me quite a while ago at a microscope. So here these are a couple of petri dishes on my bench. The bench is a little bit messy, don't judge me. And here's a microscope that I'm using. I'm actually picking out the tiny islets that I just took out of a mouse, and I'm getting them ready to put into that little device that I showed you earlier. Here I am at something called Soapbox Science, so that's doing a lot of science outreach in the community. Here I am at another one of those events, and then here I am again at an advocacy event. So if you guys have any questions, please let me know, but I hope you've at least taken away something from my talk today. If it is anything that you take away, I hope you take away these things from my talk today, and I welcome any questions. Thank you.